Well, hello everyone. It's time for another security webinar. I'm your host today. My name is Ram. I work on a bunch of different open source security stuff, and I've been doing like a series of sorts with folks from AccuKnox who are leaders and pioneers and visionaries and all of those quadrants put into one as far as security goes in the cloud domain. And we've been having conversations with various people about um, different aspects of security and things like that. And today we have a topic that's something that's rather popular within the cloud native space. I mean, I've heard of this whole thing about securing Kubernetes several times, and always leaves me wanting more. So, to discuss Kubernetes security and a little bit of hardening and a little bit of better security posture for container orchestrators, we have with us Rishabh. Hello, Rishabh. Do you want to quickly introduce yourself?
Yeah. Uh, hey guys. I I'm Rishabh. I work as a software engineer at AccuKnox. I also maintain the KubeArmor project, which is a CNCF sandbox project. And yeah, it's nice to be here talking about security with Ram. Yeah,
Rishabh, can you type something for us?
type something for you.
Just type. I
Okay.
want to hear your keyboard because I think you have a mechanical keyboard, if I'm not wrong.
Yeah, like not sure how did you make that out.
So, as a mechanical keyboard nut myself,
Okay.
I heard you type a little something when we were backstage, and I said that's going to be my big introduction today. So,
Okay.
I have to know what keyboard, what keycaps, what switches, everything.
Okay, yeah, that's rather an interesting question. So it's a Red Gear MK881 Invader. So yeah, it's a hefty name, and it's brown switches. I think it's Ottoman brown switches, and yeah, it's a I would say it's a rather silent keyboard when it comes to mechanical keyboards because blue switches are very loud in my opinion, and it's fun to type
I
on
am
it.
a blue switch person. Don't offend me.
Well, blue switches are too loud for, yeah, I would say myself. So,
Sure, sure. Everybody has their preference. Uh,
right,
You'll be surprised how many people watching this will be more interested about a keyboard conversation versus a Kubernetes security conversation, but that's not what we are here for, are we?
right,
So let's get into it. But before that, just a couple of quick housekeeping messages. More interactive, the better. So if you have any questions, please type them out on chat. If you're watching this on LinkedIn, if you're watching this on YouTube, if you're watching this somewhere on Twitter, just type stuff out. If you have questions, just drop them. We'll be monitoring all of these channels and feeds, and we'll bring the questions in as we go along. It'll keep the whole conversation much more lively and interesting. But otherwise, Rishabh, let's get started. The floor is all yours.
right. All right. So, we'll be talking about securing and hardening Kubernetes using KubeArmor. Um, can you just go to the next slide? Like, do I have the control or is it with you?
You can say next slide, and next slide will appear.
Okay. I guess then next slide it is. Right. Thank you. Um, so we'll talk about why is there a need to talk about Kubernetes security in the first place, right? Well, there are several topics to cover. Preventing unauthorized access and privilege escalation, right? Somebody misplays a kube config or just some attack that happened on your pod and it's a privileged pod, somebody gained privileged access. Protect against data breaches, integrity violations, and confidentiality issues. Right. These days, Kubernetes runs everything from databases to like confidential computing stuff, like right production environments, whatnot. Safeguarding network communications and resources. Kubernetes is a complex environment, thousands of pods running at at a single point of time, right? Securing that is a critical task. Ensuring operational resilience and availability, right? So basically, your workloads, resource management is also very important. That falls under security, because in case they are compromised, somebody could basically, like kill your CPU or RAM usage, and your node would go down, stuff like that. Maintaining compliance with regulatory requirements. This is pretty straightforward, right? Yeah. Next slide, please. So let's talk about what security options by default today we have with Kubernetes. Like, let's say somebody today starts with Kubernetes, and they've spun their first deployment, and they're just wondering, like, this is very baseline. What do I do to have more control over my workload, right? So you have a bunch of options: authentication and authorization using RBAC. So you have service accounts, you have roles, you have you know uh, role bindings, and they basically help you define the consortium of your pod. You know, Basically, what in what boundaries does your pod operate, right? Or your workload operates. Then we have pod security standards. They basically uh, they are basically recommendations from the Kubernetes documentation, which tells you that you could use a baseline policy, restricted policy, and privilege policy based on pod security context, and that help you basically a noob, like someone who's starting out with Kubernetes, right? They don't know anything. They could basically refer to these standards and help themselves out when it comes to, yeah.
So, if I understand correctly, these are all options and configurations that are available with default Kubernetes clusters,
Yes,
right? These
yes.
aren't specific tools or anything like that. These are just things that these various areas already offer.
Exactly, exactly. Like,
Okay.
so pod security context is basically what Kubernetes provide out of the box. So you could define that in your YAML, and there, app armor policies, seccom profiles, what sort of capabilities you want to set, what user do you want to run it as, do you want a read-only file system, stuff like that. And because that is a little complicated for a newbie to understand, you basically have pod security standards that help you define them, or in a broad structure. You have admission controllers. I think everybody has heard of KuberNo or OPA, right? Or Kubernetes admission controls as well, which help you basically restrict what you want your cluster work with or not, right? Basically, if somebody is trying to ingest manifest, right, with resource limits that you don't like as a cluster admin, then that can get rejected if you consider configure an admission controller. Scanning the container images, there are solutions like Trivi, which basically says that we can scan your container images, and before you send them to the cluster, we make sure that if there are any vulnerabilities, we tell them to you, and you can mitigate those vulnerabilities and then send them to your cluster running a secure workload, right? Scanning them for misconfigurations in YAML's deployments, right? This again, something you did not meant to do, but it happened because there are so many YAMLs to uh, cater for, right? So yeah, we can go to the next slide. Yes, right. So let's talk about why runtime security matter, right? I talked about admission controllers. I talked about pod security standards. They are, if you think about it, they are basically static security measures. You once configure them, then you're done with it, right? But what happens when attacks happen at runtime, right? Like, let's consider an RCE attack, right? You have a workload running which is vulnerable to an RCE attack. An attacker is able to exploit that and gain shell on your system. You don't want that to happen. Or maybe something like a zero-day attack, right? Something like Log4j, which you can't prepare for, right? So our cycle today looks like you have static image scanning, which would improve basically involve tools like Trivi, Clear, or Qualys, and then you have admission controllers like Kuberno, Kuwarden, OPA, uh, which basically say that a manifest should look like this, and if it's something else, it gets rejected. Then you have security at runtime, right? uh, which obviously KubeArmor, Falco, Tetragon, right? Tools like this enforce. And so, yeah, basically, the idea is that when your application is deployed onto the cluster, uh, that's where runtime security comes in. We'll talk about it more in the coming slides. So, yeah, this is the high level overview. Next slide, please. All right, limitations of pod security context, right? We talked about it earlier, uh, but basically, what are the problems that you face with it, right? Native AppArmor has SLNX SecCom policies for pods, right? AppArmor, for those who have used it, it's quite complicated to understand at a first glance. It's quite it gives you a granular approach to configuring your security, but it's difficult, and it's a native approach, right? It's not a Kubernetes native approach, but rather a Linux native approach. Same goes with Linux SecCom policies for pods. Native policies are hard to specify, right? Not all OS images support AppArmor. You might have nodes running with different OSs, right? And if you want standardized policy for your cluster, maybe you can't do that. Security profiles updates are difficult, right? If you want to make a change in your security posture because there is an app update, right? Now you're using a different version of your workload that needs a security change. That is, in my opinion, like a tedious task. No alerting for LSM violation. AppArmor, if it actually blocks something, AppArmor also does runtime security, uh, right? And if it detects something, then you can't get a log for it. For example, you basically have let's say, an allow-based policy using AppArmor, where you say that the pod was only allowed to do this and nothing else, and then somebody actually, violated that policy. You don't get any alerts for it, so you are in the blind, right? Yeah. So these are some of the limitations we have with pod security context. Next, yeah. Right. So here comes KubeArmor, right? KubeArmor is a CNCF sandbox open source project. It uses eBPF and BPF, LSM, and AppArmor as baseline engine for enforcement. It's an inline mitigation solution. Uh, it helps you achieve container hardening. You can configure zero trust policies with it. It also helps you with network segmentation. And most importantly, we are talking about Kubernetes. So KubeArmor policies are Kubernetes native, just like any of your deployment YAML or let's say service YAML. You would find KubeArmor policies very similar to that, right? So yeah, a little bit about
Now, can we go back to the previous slide? Sorry.
yeah.
Yeah, so comparing what you showed in the beginning as to what Kubernetes has in terms of default security with this list here, are
Right.
these reusing a lot of those primitives, or are these built on some other features
Well,
of Kubernetes and things?
it's both actually. Well, I talked about AppArmor, right? KubeArmor today uses AppArmor internally to enforce those policies for you. But the USP is that instead of configuring AppArmor, on individual workloads, which is a tedious task, and updating those policies in case your workload changes, right? That's a tedious task because AppArmor policies are difficult to configure. KubeArmor allows you to configure those using YAMLs. We also use BPF LSM, which is something like AppArmor, which is not Kubernetes native. So it's best of both worlds, I would say.
All right,
Yeah,
thanks.
yeah. So fundamental difference in runtime security, right? Uh, we talked about KubeArmor, we talked about AppArmor, but there are other tools out there as well. So Aquatracy, that also does observability, something that we did not discuss yet, which is eBPF. eBPF, Kubernetes, and eBPF are going together a lot these days on online forums. People are talking about how they are doing observability with eBPF, and the idea is that with eBPF you are able to trace system calls. System calls are basically the fundamental units of Linux that identifies a process is trying to go into is executing, right? So Tracy, Falco, and Tetragon, for example, Tracy does a kill process from user space, whereas KubeArmor follows the inline mitigation system, right? So with Tracy, what happens is that let's say an attack happened, right, and Tracy detects it, but it kills it in user space. So you're too late basically. You're doing post-attack mitigation, what we call it. With Falco, Falco is not an enforcement engine, meaning that it can detect attacks for you, but it can't stop it. With Falco Talon, which is a plugin to Falco, right? You could say that, let's say an attack happened on a pod, let's say a ransomware attack, right? And now you're logged out of your system. Your data is logged. You can't access this. So with Falco, you could say that if something happened, then kill the pod itself. Talon, Falco and Talon. So that's there. With Tetragon, you do have BPF send signal, which is a kernel, basically, I would say a function which sends a sick kill for an for a process that is malicious, but that is still asynchronous and could lead to like leaks. So that's also considered post-attack mitigation. But with inline mitigation, what KubeArmor offers is that we deny, uh, you know, a process before it can do anything. So we basically kill a process at execv. Execv is again a system call, but not just not going into deep details. Basically, you get inline mitigation. With KubeArmor, you can be certain that your attacks are not going to harm your system. So you don't, not only do you block it, do you detect it, but you are safe. So that's the differentiation. Yeah.
So there's two phases you're saying. One
Okay.
is as the attack happens or during some malicious activity itself, and then another phase where after detecting particular malicious activity you decide to take certain action.
Correct. Correct. So
And
yeah.
one set of tools are able to help with one thing versus another set of tools are able to help with both.
Well, I would not say that it's both. See, the point is that if an attack happens, an attack is basically a process. And
Sure.
Tracy, Falco, and Tetragon, they're basically doing post-attack mitigation. So the damage is done, the process is executed. Now you're trying to kill it, right? For example, with Tracy, you're doing a user space kill process. With Tetragon, you're doing a kernel space in process, sick kill, but that does not work always. And with Falco, you don't do it at all. You have a Talon, but that also has its limitations. But with KubeArmor, what we say is that an attack is about to happen, and you stop it right there, dead in its tracks. So yeah, with other solutions, you might say that you suffered damage on your infrastructure, but with KubeArmor, you can be certain that that's not possible.
Okay.
Yeah, we can. All right. So HashiCorp Vault use case. This is we are also going to do a demo for this. So basic point is that if you want to manage secrets for your workloads, right? One option is that you basically configure a secret, Kubernetes secret, and then you mount it to your pod. But that's insecure design, in my opinion. What people use today for securing their secrets is basically a vault. So a vault says that it is a centralized store for storing secrets, and every workload that requires secrets basically can borrow it from the vault, right? Uh, so individual workloads don't basically mount secrets, but vault has they request it from a vault, which is a centralized secret store, right? Uh, am I like going too fast? Is it
No, no, no. I think everybody understands what a vault is. So
right?
go
Right,
ahead.
correct. So yeah, so basically vault becomes a centralized store of failure as well. Centralized system of failure, because everything is there. If an attacker is able to compromise a vault, right, then it's game over for you. Yeah, we can go to the next slide. Right, so let's imagine an attack, right? A ransomware attack sweet spot, right? Let's say a ransomware attacker was able to compromise your vault, and they're able to put a lock to it, right? Now every secret on your cluster is basically on a lockdown. No workload is going to be able to access any secrets because the centralized secret store is compromised, and you don't have access to it. And organizations now will have to pay a hefty fee for getting that out, and that's not even a guarantee, right? Yeah. we can go to the next slide. With KubeArmor, right? We say that. So let's understand, like how does KubeArmor help you secure your vault? Basically, an attacker is going to spawn or a new process to compromise the vault, right? We know that bin vault is a known process, and we with KubeArmor we say that we create a policy saying that only bin vault it is allowed to access the mount volume mounts, which are vault data and vault config. Any other process, if they are going to access vault data or vault config, they are going to be denied. So only bin vault is allowed to access those data points, and everyone else is denied, right? So even though you are running a vulnerable version of vault, let's say an attacker is able to compromise it, you're still safe with KubeArmor, right? Uh, yeah, let's start with the demo. I can share my screen, and just a second. Yeah, yeah. You can see my screen, right?
Yeah.
Right. So let's look at the vault, right? Uh, I'll log in here later, but let's move this away. Right. So we have a vault running here, and let's create some secrets first. I'll log in into the vault. I have the secret for it right here. Secret engines. Let's say it's my first secret, and it's a password, and not so secure, right? So I'm just going to add a secret, and if I now look at the vault, you can see that we now have a folder which basically contains the data for my first secret, right? Now consider that I'm an attacker and I just have a shell on this vault pod, and if I go ahead and delete it, right, as you can see, I've deleted it. I have to log in again. All right. Yeah, you see that there is no secret here, right? So basically, considering that I'm an attacker, I just went to the vault, I deleted your secret, and your vault is now compromised. Now, let's try to enforce a QArmor policy, right? And before I do that, I'll just discuss a bit about the policy, right? So this is what a KubeArmor policy looks like. You can see that it's very similar to what your other Kubernetes resources look like. And we basically say that the vault directory, which contains the secrets, right? It's a block action for it, and it's a recursive call. So you basically block this directory, right? Uh, but you allow bin vault to actually access it, right? It's an allow policy, and it's actually a zero trust policy. uh, I'll basically explain what a zero trust policy is. It's a policy which basically says that certain workloads are allowed to access certain resources and everybody else is denied, right? So even though if like your any attack happens, it's a RC, it's an LFI attack, it's an RFI attack, right? They are going to be denied. So it's a zero trust policy. and it allows bin vault to access the vault, and everything else get denied, right? So I'll just deploy this policy. First, let's create the secret again. My second secret, and it's a pass, and let's see, right? We have now the secret here, and I do a KSP. Okay, right. So I have the policy right here, and I'll just deploy it. Right, you get a permission denied now, and you basically can't do anything if I, like, try to catch something or anything, right? Like, I can't even list the file, so surely I can't cat anything as well. So the idea, you get the point, right? You're not able to access it now, and but your vault still runs, right? uh, like I previously discussed that bin vault is still allowed to access this directory, right? And that can be proved if I try to create a secret. My sorry, right, you get a success because the main process is still allowed to make changes on the mount point. So that was the use case with vault. Now you could say that your vault is secure and you're not worried about zero day attacks or RC attacks, stuff like that, right? And but let's say that the attacker wants to use the package managers present on your pod, right? For example, we have a APK here, and I want to showcase another policy that you know is a block policy. This is not a zero day policy, but basically what it says is that anything that is APK, a binary named APK, you block it, right? So right now you can see that APK is running, and I'm not getting anything. I'm able to access it without any issues. So I'll just create this policy as well. Okay, let's change the name. APK protect, right? And right, so you get permission denied on this one as well. So these policies are just an idea, what you can achieve with KubeArmor. uh, I'm sure if you can get creative, you can create your own policies. You would have different workloads, right? And KubeArmor allows you to have fine-grained control over these, right? And with zero trust policies, you can have an allow policy which allows something and then has everything else, so you're safe, right? uh, okay, I'll just stop sharing and we can continue with the slide deck. Right. Yeah. So this is how this is a overview of what's the design of the KubeArmor host policy. Right now, what we discussed was KubeArmor policies for containers of a Kubernetes. We support Docker as well in non-orchestrated mode. Unorchestrated mode, we support Kubernetes, but this is KubeArmor host policy. In case you want to use KubeArmor on a bare metal VM, you can do that as well. And this is the structure of the policy, right? Yeah, we can go to the next slide. Right. So we already saw, right, how KubeArmor protects. your vault, and you can configure a zero trust policy. You allow the vault binaries, right? And we support all major cloud providers: GKE, OpenShift, Azure on-prem, right? EKS, whatever your choices, right?
Is there a distinction between any of these providers in terms of what they do for security primitives on each of the hyperscalers?
Right. Yeah. So, for example, I'm aware about EKS, right?
Sure.
EKS has a bottle rocket OS, right? Which they specifically configure for security. So, for example, BPF LSM, which is the latest and newest you know LSM that even KubeArmor integrates with. Uh, Bottle Rocket comes with that, and BPF LSM allows you to have the most fine-grained control over what your program can do and not do. So that's something. And I think with OpenShift they have, I think it was SecCom profiles, if I'm not wrong, pre-configured on their clusters. So their clusters are actually somewhat secure by default as well.
That's good to know. Because a lot of times I've found that there's these very tiny pedantic variations among what's
Right,
provided by the hyperscalers. And um, yeah, I just wanted to make sure.
right, yeah. I think we can go to the next slide. Right, yeah. This is a repetition, but I just put it there to like to make a map of what we talked about today. You get the point, right? Basically, it's inline mitigation, and you stop your attacker dead in its tracks, and yeah, that's the point. I think, is there another slide?
Well, somebody on LinkedIn says, excellent presentation. I have deployed KubeArmor, but I'm struggling with the volume of logs that the service generates. I mean, you kind of signed up for that, but do you have any questions about, or do you have any comments about
Right,
how
yeah.
they can manage logs better? And
Right, right. So there are two parts to KubeArmor when it comes to logs. We have alerts, right? Alert would be a policy violation, which would basically say that. In fact, I would I would want to share my screen. Actually, I had to show this, but I forgot. Anyways, I'll just show it in a couple of minutes. Okay, export. Right. So this is what an alert actually looks like. Whenever a policy is violated, as I said before, with limitations of pod security context, that you don't have any LSM alerts, but with KubeArmor you actually do. And it gives you all of the information, right? You might be running thousands of containers, but you do get container name, you do get container ID. In the policy where we set what severity is it, for security teams it is, and crucial for them to understand by tagging and setting security like severity, and then messages on the policies, right? Just to distinguish between the policies. So you get all of that. You also get the process name, which was actually blocked. It tells you about the enforcer. As I said, we use PPFLSM, right? And yeah, so this is what a policy violation would look like. But let's just say that one more feature that I want to showcase is what we basically uh, yeah. So you might have number of policies configured for KubeArmor, and I'm sorry if I'm just digressing from the question. I'll come back to it pretty quickly. But basically, with KArmor Pro, KArmor is our helper utility. It's a CLI tool with KubeArmor, and it can basically help you execute functions, get some information. and it allows you to basically know what all pods are configured with what all different policies, right? For example, the vault pod is configured with two policies, which the one which blocks APK, and the one that protects the vault directory, right, which you saw earlier, uh, right, with the KubeArmor. Okay, let's just help. Yeah, with KRMA profile, if there are any, right? So with KRMA profile, let's say you don't have a policy, you don't want to enforce anything, but you just want to know what your container's behavior is looking like. Uh, so that actually you can get with KRMA profile. So it talks about real-time data on what's happening in your containers, right? Through a TUI. So that's also available as well. But just answering your question, um, so QArmor with context to logs has two types of logs: alert, as I showed you before. Then we have logs, which are visibility logs, which basically mean that if you don't have a policy configured, right, for a pod, but you still want to track its behavior, you can have the visibility on it. And global visibility is controlled via a config map in the KubeArmor namespace. If you do kubectl get config map, you'll see a KubeArmor config map there. And if you try to edit it, you'll see that there is a visibility setting there, right? And that is by default set to process and I think network. If you don't want it to generate all of those visibility logs, which are not related to policies, you can just set it to none, or maybe process in your case, whatever suits you best, right? And I'm sure you will generate a lot less logs from visibility, right? So yeah, that would be something.
Yeah, I think they just posted a bit of a follow up as well. Is there a way to restrict logs to specific namespaces or events?
There will be to restrict logs to, right? Yeah, yeah, sure. So KubeArmor has this annotation, right? Getting container visibility. Yeah, I'd like to share this. Uh, we don't have the chat access here, right? For the global chat.
No, but if you paste it
Okay.
somewhere, we can get it to them. Yeah.
All right. Yeah, I've pasted it. So
All right.
this uh, document that I've shared in the chat is basically a setting for visibility. If let's say that there is a particular namespace that you want logs for, right, then you can annotate that namespace with the setting that I have shared in the document, and that will allow you to set certain settings, certain visibility settings for that particular namespace. And through the config map, you can control the global visibility settings. So maybe you want logs for just one namespace, and you can just deny the rest.
Yeah, I think that was a good question. Logs can get overwhelming,
Yeah,
and
definitely.
be useful to limit them, etc. But it was great chatting with you, Rishabh. That's a lot of things for people to sort of digest, and I like the fact that we went from something very basic to understanding what the concepts are, and also looking at a demo that sort of would help internalize a lot of these things. So thank you so much for that. If folks have questions and things, Rishabh can be reached through.
Yeah. Okay. Somebody asked. Form. KubeArmor pods can be reformed. Like, if I understand this correctly, then the Kishore is trying to say that if KubeArmor restarts somehow, or
No. So if you have a pod and there's some policies that you've applied using KubeArmor,
right,
and then after an attack they decide to restart the pod, like maybe delete it or crash it or what have you. So
right,
is the same policy applied on the new pods?
right. Yes, the answer is yes. As long as you don't change the label on your deployment on your pod, KubeArmor policies are matched to workloads using labels. So there's a
Hmm.
match label field on the policy which helps you dictate that, okay, so I have put this label on the pod. I'll mention the same in the policy. And as long as the pod has the label, it doesn't matter if you restart it, if you delete it, it'll still enforce.
All right. Yeah, we're getting a lot of interest and questions. Just that we're running out of time for most of them. But like I was saying, if people have follow-up questions, they can reach you where?
They can reach out to me on LinkedIn, and on Twitter, you'll find me by the username RootXRishabh. And on Slack, you can join the CNCF Slack, and where we have the KubeArmor Slack channel. And anything you ask there, we'll be very happy to answer that.
Got it. So I'm going to reverse that order. So find the KubeArmor Slack channel. That should be your best way to connect with the community. And obviously, there's individual socials that you can reach out to. Probably best to keep it to Slack. But thanks so much, Rishabh. It was nice doing the session with you today. We've covered a lot of great information. I hope people will benefit from this, not just like watching it live, but also when they come and replay this at a later date. So
Right.
thank you for all that. Quick reminder: we don't have a session next week. Our next in this series is going to be on the Wednesday that follows. I had the date open here in one of my 57 tabs. So on the 7th of May, same time, Wednesday, 7th of May, we're going to have another webinar. And that one's going to be somewhat balancing the engineering side of how security gets built and sold in organizations, and so engineering plus sales and a lot of conversations that happen. So I expect it to be somewhat entertaining, and obviously a little bit informative too. But I really look forward to seeing a lot of you on that session as well. Thank you so much for tuning in. Have a great time. um, Thanks. Bye bye.